All right, so this is the next problem. This is problem 31. And this one was just the integral of 20 times tan to the power of 6 of x dx. And so this is how this one goes. Basically, I mean, the first thing I want to kind of mention is that there's a lot of trig identities and a lot of like half angle formulas, all these formulas, but I will say that the most important ones for these problems are the basic Pythagorean identities. So I mean these ones, like the sine squared plus cosine squared equals 1. And then from this basic one, you get this one, right? You get tan squared equals secant squared minus 1. So this one comes from this one, right? You just divide through by cosine squared here, and you get this. And so these two are the most important trig identities to really know for these kind of problems, along with, of course, all the derivative identities. Like the derivative of tangent is secant squared. That's going to be useful in this problem. So yeah, I don't know. That's just kind of a point I wanted to make. I mean, if you really had to remember just one, these are the ones that are going to be the most useful and they're going to come up the most. So that's what's going to happen for this problem, basically. So like we have tangent to the 6 of x. And remember, like we basically kind of want a secant squared to pop out, right? Because if we have secant squared popping out here, then we know that the derivative of tangent is secant squared. So then we can use some sort of u substitution, just like how we did on the last problem, right? The last problem we pulled out a sine because the derivative of cosine is sine, so we can do u substitution. So a similar thing is going to happen here, right? So a similar kind of strategy. So this is what it's going to work. So we have tangent of 6. We pull out a tangent squared, and then we can use this identity. We know tangent squared is secant squared minus 1. And there's our secant squared. That's going to be useful for the u substitution. So at this point, I'm just going to distribute the tangent. And now we have two integrals going on here. We have the first integral when the tangent gets multiplied here. And then when tangent 4 gets multiplied by the minus 1, we have this integral there. And then the constant of 20 is still just kind of multiplying outside. It's multiplying the whole thing. Okay, so at this point, we kind of like split up this integral into two separate pieces, and we'll kind of do each piece separately. So this piece, you should know how to do this quite quickly because this is the whole reason why we use this identity. Because look, this is tangent 4 times secant squared. The derivative of tangent is secant squared. So we're going to do a u substitution where if you set u is equal to tangent of x, then du is secant squared x. And look, that's exactly what we want because it's right there. So now we can do u substitution. What happens? It simplifies down to just the antiderivative of u to the 4. And we can do that, reverse power rule, and then substitute back in. And then that's the antiderivative of this guy, right? So we have that piece. Okay, that's good, cool, great. So that piece is done. Now we just need to figure out what this evaluates to. Okay, so this is tangent to the 4. Okay, so tangent to the 4, we're basically going to do the same thing. We're going to pull out a tangent squared. We pull out a tangent squared, so now we have tangent squared times tangent squared. But the tangent squared, we use the identity, secant squared minus 1. So we can rewrite this into this, and then kind of split it up again into these two pieces. And then what do we have? This is the same thing, right? U substitution. We have a secant squared, we have a tangent. That's a good situation, right? So you want to set u equals tangent, and then du is secant squared x. So we have it here. U is tangent, du secant squared x. So now we can convert it into this guy, right? So that one's good. This one is just a u substitution. What about this one over here, right? Because this one over here came from distributing this to this side. So that one right here, integral of tangent squared x. Again, I mean, okay, tangent squared x, just use the identity again. We know tangent squared is secant squared x minus 1. And can we compute this integral? Yeah, we can, because what is the antiderivative of secant squared? We already know that's tangent. So this one can be done just off the bat right away, right? So the antiderivative of this one is tangent x minus x, right? Take the derivative of tangent, secant squared, derivative of x is 1, and then there you go. And then from this one, like I said before, we just do the u substitution again, and we get integral of u squared. Okay, reverse power rule, substitute it back in, and then there we go, right? So that's that. Cool, so now we're basically done the problem. We, to recap, we, split it up like that. We did each part separately. Now we're gonna just add it together. Okay, and then basically you get that, boom. That's the final answer there, right there, right? Yeah, and that's it.